Hello everybody, and welcome to a special follow-up Tech Talk. In the last video, I began serious testing of Debian 12 Bookworm for my production machines, and for eventually upgrading my cloud servers a few months down the line when the new release has settled down. That was a simple Calamares install with BTRFS timeshift for rollbacks and recovery. Why BTRFS and not ext4? It's included in the kernel, it provides transparent compression, it's copy on write, so only changes are included in the snapshots. All fantastic for the long-term health of my SSDs. Today, I would like to demonstrate a so-called expert install of Debian with a full BTRFS subvolume layout, snapper, and bootable snapshots, all on an encrypted root file system. But before I dive in, please consider supporting this channel and smash that like button. It really helps with the YouTube algorithm. Thank you. Let's go right after this. Today, to save some time, I'm going to be using the latest live GNOME ISO. See link below the video. Okay, let's go to Advanced Install Options. Graphical installer with dark theme. Hopefully it'll be more legible for you guys. Expert install. We'll choose the language. English, United States locale, and no additional locales. Continue. American English keyboard, detect and mount installation media, USB storage, auto detection is successful for the CD-ROM image. For the installer components, I won't need to add any additional components. We'll just go with the defaults here. Detect network hardware. This is a KVM virtual machine, so it's already connected. We'll do the defaults for configuring the network here. And configure network with DHCP should succeed, and it has. And standing by. Okay, host name. This is a testing machine, so we say d12-test. Okay, domain name will leave blank. Set up users and password. Not allowing root as login, we want to use sudo for the Steven user instead. I'm going to give myself a password. Okay, continue. Configure the clock. Yep, we set using network time protocol. The Debian pool is good. I'm in the Pacific time zone. Let's detect the disks for the target to install. Okay, looks like it worked. No news is good news. Let's partition. So today we'll use the guided use entire disk and set up encrypted LVM. And my virtual disk looks good. All files in one partition because we're using BTRFS and subvolumes. So let's configure the logical volume manager. This is a blank disk, so we will cancel the erasing. And move right on to the encryption passphrase for the root encryption, LVM, logical volume. And let it partition the disks automatically. I'm going to have to fix for BTRFS. Volume group name looks good. Yep, that's the volume group we'll need. And let's go ahead and you see we have swap and ext4. We want to remove swap and use ZRAM instead and BTRFS instead of ext4. So our current details for the configuration is there. So we need to delete root and delete swap. Let me do that quickly. And create a single logical volume, namely root. So swap is gone. And that's intentional because I'm using SSDs. I don't want to have swap on them. So that's the configuration. So we'll go ahead and select Finish. And so this is our logical volume, root logical volume. So we'll use it as a BTRFS journaling file system. The mount point will be /, which is, of course, the root file system. And we're done setting up the partition. So everything else looks pretty good. Notice boot is outside the encryption zone, and that's okay. The Debian installer won't allow encrypted boot for various reasons. So no, we indeed don't want swaps, so we'll go ahead and write the changes to disk. And now, before we install the system, I'm going to switch to the Control-Alt-F3 BusyBox console. That's a small text, guys. I cannot make this larger because BusyBox just doesn't allow me to have it. Anyway, so here are our file systems currently mounted. So let's unmount the target file systems first. Step 1. You've probably seen this before in other videos, including mine. And then we're going to mount dev mapper, and the volume group for root is D12 blah 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 on /mount. And then we'll change directory into /mount. And as you can see, it already did a @root file system subvolume. We're going to rename that to @ make it compatible with timeshift if you want to do that. And we're going to create some additional subvolumes, snapshots for Snapper, home for the home subvolume, @root for /root for roots home directory. Same for log. This is a GNOME specific setup, so I need to create an account service subvolume. GDM, temp, opt for /opt. Images for my virtual machine KVM QEMU images. Huge files, don't want that part as the default snapshot. And also my containers for Podman and DistroBox. Good, so let's mount these subvolumes. So first, the @ subvolume. To use for my SSDs, no access time and compress equals Z standard level 1. We'll mount that on /target. Cool. Space cache and SSD options, those are automatic. So I need to include those here in a modern kernel. So let's create the mount points. Boot EFI.snapshots, home, root. All these subvolumes need their mount points. So var log, varlib accounts service for the GNOME display manager. We're running GNOME today. GDM3 for the same reason. Temp, opt. VirtualBox likes to install an opt. Varlib libvirt images, that's where my KVM images live. They're huge. Again, don't want that part of the regular root snapshots. It'd be crazy disk usage if I did that. Varlib containers for Podman container storage, system-wide. Okay, let's mount the rest of the subvolumes. @'s already mounted, so let's do snapshots. And they'll be on /target /.snapshots. Same for @home. That'll be on the target root file system /home. Do again for the root home directory. not the root file system, root's home directory. We want to keep that separate in case we need something there during snapshots and rollbacks. Same for var log. Get the mouse cursor out of the way. Do accounts service. Again, this enables GNOME Display Manager to boot from read-only snapshots via grub, which is what we want to do today. In addition, we need the GDM subvolume at GDM, and they'll be mounted on target var lib GDM3. Don't forget the 3. And then we'll do the temp directory /temp, which is on /target/temp. You see how this goes. Even if you can't read it too well, sorry about that, folks. This is as big as I can make it. Do the same thing for /opt. For the images subvolume, at images, we target var /lib/libvirt/images. Tab completion is your friend here. Also up arrow for history. Saves a lot of typing today. Containers from my container projects. They live system-wide containers, live in var lib containers. Cool. So that looks good. Let's mount the boot partition and then mount the EFI partition. This is an EFI machine today. Last video was a BIOS legacy machine. We're doing EFI today because that's what most of my target machines will be. All of them, actually. I don't have any BIOS machines left. So let's update the file system table under etc/fs tab. So the Debian installer pre-created this file, but I need to adjust it because I made some changes. And I'm going to add my special sauce, my mount options here, no access time. Keep things as light as possible for minimizing wear on my SSDs, my solid-state drives. If you have a spinning hard drive, you don't have to do much of this. You probably wouldn't have to use BTRFS anyway. Cool, and I'm going to hit Control-K and then Control-U, and then I'm going to add 10 more lines because I got 10 additional subvolumes I'm going to have to do here. Those are 10. So I'm going to add /.snapshots, and that'll be at snapshots subvolume. Then I'm doing home, /home, subvolume is at home. Next, I'll do /root for the root home directory, at root. And then I'll do var log for the at log subvolume. Next, I do var lib account service for the accounts service subvolume. Case sensitive, remember. Everything's case sensitive in Unix, or almost everything. Next, /var/lib/dgm3, and I'll be at GDM subvolume. Almost done here, folks. Typing as fast as I can. /temp will be subvolume at temp. /opt will be, you guessed it, subvolume at opt. /var/lib/libvirt KVM images here will be subvolume at images. And then finally, var lib containers for my podman will be living on subvolume at containers. And there we go. Let's save this, our changes. Cool. Let's go to the root directory and unmount /mount and exit. Here we go. So I'm going to go back to Control-Alt-F5, and now I can install the system. It'll be a normal installation, not a live installation. So Again, I'm using the live ISO because I don't want to spend all and waste your time downloading all the packages from the network. So you can see that happens fairly quickly, even with my editing. Let's configure the package manager. Let's use a network mirror, HTTP fine. I'm in the United States, and my mirror that really works is Oregon State University Open Source Lab, this one. So I'll select this as my mirror. It's super fast. Continue. Yes, non-free firmware, non-free software. We'll say yes to all of this. And no to source. We don't need that for this demonstration. So I configure the apt. And I also add, in addition to security updates and release updates, I like to add backported software. Who knows, it might be useful in the future to have access to backported packages. Okay, let's install Grub bootloader. I'll just go ahead with the defaults here, continue. No OS prober. This is the only operating system on this disk, so we don't need to probe for other operating systems. So we'll go ahead and finish the installation. Installs a whole bunch of stuff from the network, I think, maybe. Yes, it is the clock set to universal time coordinated. So we go ahead and let it clean itself up, and we're ready to reboot. Let's do that. Continue. Okay, here we go. Let's go ahead and boot the freshly installed system. Please unlock the disk. So I'll enter my encryption password here. And there is GDM3. This is going to be a Wayland session, which is what I need. GNOME is, for me, the simplest and quickest way for Wayland. We'll just click Next here. Keep things moving along. And this video as short as possible. I'm going to switch to dark mode since most of you prefer it, and I prefer it as well, or my eyes do rather. I'm going to switch over to the default wallpaper again because I like it so much. And I'm going to turn off screen blanker. Automatic suspend should be off for demonstration machine for displays. Let me fix the screen resolution and switch it to 1080p. Click apply. That of course makes the fonts tiny. I'll fix that momentarily with tweaks tool, which is included in the default install. Very handy. Cursor theme will be Adwaita. Icons will also be Adwaita. Legacy applications will be Adwaita Dark. And I'll fix fonts here. Hopefully that's more legible. 15 points and everything. Okay. For the disable touch typing, minimize, maximize buttons, focus on hover. Okay, and there we go. Hopefully it's legible. So we go ahead and do a sudo-s. So sudo is working. I can become root at d12-test. Let's check the OS release file. As you can see, we are indeed Debian 12 bookworm. And this is it's a 10 gig install, basically. Those are subvolumes. We don't have to worry about partitioning here. So this is the list of subvolumes. They're all top level 5. Let's do a quick update. Sudo update and apt update rather, and apt upgrade. It's mostly Firefox stuff since this ISO was released a week or so ago. Let's reboot and launch into, after we type in the encryption password for root. We've got a freshly updated system here. And here we go. Let's go to terminal. All right, let's become root again. Sudo-s. There we go. As you can see, we haven't configured swap, right? We're on SSD. I don't want swap on my SSDs. So let's enable ZRAM, right? So let's apt search ZRAM, and our package we want is ZRAM-tools. So I'm going to go ahead and install it. Apt install is ZRAM-tools. There we go. It's installed. Now if I do a free-h, you can see we have ZRAM swap enabled. Only 255 megabytes, which is a bit small for my tastes. I generally like to fix that. Let's check the compression level that we currently have for ZRAM 0 device, block device. So the compression algorithm it's using is LZ4, which happens to be the fastest. So all we need to do is edit the, with Nano, the etc default ZRAM swap file, configuration file. So you can see LZ4 is the fastest. And I'm going to uncomment %=50. I found that setting ZRAM swap to 50% of physical RAM seems to work best for me. So let's restart the ZRAM swap.service and then check free-h. And as you can see, we have almost 4 gigabytes of swap available. So the kernel, Linux kernel, is happier with swap configured because that's how it's engineered after all. So let's install some prereq packages. I like firmware Linux and Plymouth themes. Let's pretty up the boot process for this virtual machine. So, and suppress messages. You don't have to do this if you prefer to see all the messages. So I'm going to edit etc default grub with Nano again. I'm going to add to the command line Linux default log level equals 0 to really suppress the messages, and splash for the Plymouth splash screen that Debian 12 comes as default. So let's update the grub bootloader with update-grub2, and let's reboot and see what happens. Okay, notice I added the firmware package, so UEFI firmware settings is now available. And here we go. Much nicer screen for unlocking the root file system. And here we go. No more pesky messages. Again, this is entirely optional. I just show you how to turn this off. All the verbose console messages during boot. So let's become root as usual, and let's install some more packages for the rest of this video. So I want snapper-gui, Git, and inotify-tools. Inotify-tools is for grub BTRFS snapshot monitoring, and snapper-gui pulls in snapper package as a dependency. So that's done. Let's go into the root directory and let's unmount .snapshots because Snapper creates its own directory here. Let's remove it. So now we can configure our first root configuration. snapper-c root create config / and then we can do snapper-c root set config timeline create equals no for this demonstration. You probably might want it yes for your own device. I'm just going to set it to no for demonstration purposes. So ID Steven shows I'm in the sudo group, so I'm going to be able to use Snapper as myself by setting the config allow groups equals sudo. All right. Also, what I like to do is sync the access control lists to make sure those permissions and everything follow through with the snapshots. We'll do the same thing for the home configuration for the home directory, like so. And then we'll do for home the same thing as we did for root. We'll turn off the timeline creation. So that creates automatically a snapshot every hour. And I don't want that to happen for this demonstration. Again, you may want to turn this on if you're lazy and forget to do snapshots on a regular basis. It might be safer to do that. Also, allow groups for sudo for home configuration. And also, we want to sync our access control lists. Cool. Now, what I'd like to do is do some more editing of the config files under etc snapper configs for root. So you can see sudo sync AC, everything, timeline creates no. Okay, I like what the ArchWiki does. If you do enable timelines, is you want to set this so you don't get overwhelmed with snapshots. So Arch Linux Wiki recommends the following settings for the timeline cleanup, so you're not overwhelmed. Again, we have the timeline turned off, but just in case we forget and turn it back on again, we already have the config for both root and home correctly set up. Do the same thing for home here. etc snapper configs home I'm in. And so I'm going through this very quickly, folks. Sorry about that. Just pause as you see fit, and you can go forward and backwards on this video. You can pause anytime, right? Okay, systemctl disable a snapper-boot.timer, because I don't want it to create snapshots every time I boot the system, because we're going to be doing a lot of rebooting today, and that would really make things murky and confusing for the demonstration. So let's remove the /.snapshot subvolume, and then we recreate it with make-dir /.snapshots. And as you can see with mount-av, we've successfully remounted the /.snapshots directory. Cool. snapper-ls shows we have a pristine system with no snapshots available. Same thing for home. Good. So, moving right along, let's do a BTRFS subvolume list. So as you can see, we have our main root @snapshots subvolume, and also for @home /.snapshots. The top level, it's a child of ID258, and ID258 is @home. So the @home /.snapshots is the child of @home. And this is what we want. Moving right along. Let's cd to the root's home directory and git clone. Let's pull in grub-BTRFS from Antonia's GitHub repository for grub-btrfs.git. cd into the directory and do a simple make install as root. Okay, as you can see, it detected snapshots, so the installation was successful. No snapshots found, of course, because we haven't done any snapshots yet, and that's fine and expected. Let's do an update-grub to make sure the grub is understood that our snapper basic configuration is functional. No snapshots found yet. So let's systemctl enable now the monitoring service for checking for new snapshots and updating the grub menu accordingly. So that you enable with grub-btrfsd service, and as you can see, it is running successfully thanks to the iNotify package. It gets notified as soon as you create a new snapshot. That's its purpose in life. Good. Okay, so let's go back and clean up after ourselves. We can remove the build directory. Let's reboot. As you can see, we don't have the grub snapshot submenu yet because we don't have any snapshots. So let's do something about that, shall we? All right, let me log in. And let me open the terminal. Okay. snapper-ls. So again, we don't have any of our snapshots. So sudo snapper-gui. Let's create our first snapshot. For the root configuration, let's call this first snapshot default root snapshot. Click OK. And there we have our first #1 snapshot. Snapshot 1 created for root. So we close snapper-gui. So let's do a snapper-ls. And as you can see, we have the new snapshot. There's no cleanup, so this snapshot is permanent unless you manually delete it. You don't want to clean up this number or something like that. So let's do a sudo BTRFS internal root ID /snapshots/1/snapshot, and the root ID is 269. So we want to make that default with sudo BTRFS subvolume set default 269 /. Notice I chopped off a lot of characters there because I'm a lazy typist. Then we run sudo update grub to let grub BTRFS know what's going on. It now found one snapshot, which is our default root snapshot that we just created. Let's clear the screen and sudo reboot. And there is our snapshot sub directory for grub. So let's select it and see if it can boot from our new snapshot, our default root snapshot. And sure enough, looking good. Yep. And we can log in. All right. So then you can open up a terminal and you can do certain things with it. As you can see, it's booted and default, so the asterisk indicates that in the snapper-ls list. So let's reboot. So booting from snapshots works. Moving right along, let's do some more tests, right? So I'm booting from the default grub menu entry here. I can't talk today. I'll try to do better in the future. All right, so sudo BTRFS subvolume get default /. So you can see it's 269. If you recall, that's the number we want. So that's the default subvolume we set. Snapper-ls shows plus, which is the default root snapshot. So it is indeed default. Sudo apt install neofetch. So let's test the autosnap by installing the neofetch package, which is my favorite testing package, one of my favorites. So it's installed. Let's do neofetch. Here you can see and ponder our installed system. Snapper-ls shows we have pre and post snapshots automatically done, but the description is kind of blank. It just shows apt. So we can fix this. We won't be lazy here. We'll fix this by going to snapper-gui and add what we've done here, actually, while it's still fresh in our minds. Install neofetch is what we did for this pre and post snapshot pair. So we'll do the same thing here by copy and pasting. Lazy typist I am. So you can see it modified both snapshots. So printed that to the console. Snapper-ls, here we go. It's a number cleanup, which means they'll automatically clean up after a certain period, depending on how you configured things. Cool. All right. So snapper status 2.3, which is pre and post. And so you can see, this shows you all the files it changed and modified and added. Changed and modified is redundant. Sorry. Okay, so sudo snapper undo change if we're unhappy with our neofetch installation. So here you go. It deletes, snapper deletes 1,295 files and modifies 15 others. And neofetch is gone. Oh, but I want neofetch back. So you just reverse the procedure with sudo snapper undo change 3.2. So it's the opposite, 2.3 or 3.2, right? So we created those 1,295 files and modified 15 more. Now neofetch should be back, and it is. Wonderful. So basic snapper is working. Let's do one more test here. Let's break the system. Don't do this on production. This breaks the system. Danger, Will Robinson. We'll break the system. We'll simulate breakage, catastrophic breakage, by removing the entire etc configuration directory. As you can see, it's gone. So the system is broken, right? So if I do sudo reboot, well, the password database has been wiped out. So we just force it off and force it back on again and see if we can boot. And check to make sure that, yes, indeed, the machine is broken. It fails to boot. So we'll go to our Debian Linux snapshots, and we'll select post, which is the most recent snapshot we made. Snapshot number 3. We'll choose the kernel. And here we go, crossing fingers. Hopefully it boots. And looks like it does. All right, see? Using bootable snapshots really helps us out of a sticky situation. So far. So ls/etc has been magically reappears. So it's a working snapshot. However, it is read-only because Snapper creates by default read-only snapshots. And we booted from read-only snapshots. So this is our default root snapshot, and the little minus here next to the 3, this is our currently booted snapshot. So the negative sign denotes our currently, like I just said, booted snapshot. Okay, so sudo BTRFS properties get -ts/, and you can see, yes, we have booted into a read-only snapshot. RO equals true. Cool. All right, so let's roll back to system. Sudo snapper --ambit classic rollback. And here we go. And so as you can see, this is what it did. So it created snapshots 4 and 5. 4 is the backup of 1. As you can see, 1 is the default. Okay, it made 5 as the new default, is what it claims. Again, 3 is our currently booted snapshot. So plus next to 5 now, as you can see. So it wants to make that the default snapshot. Okay, so let's reboot. Go here. We log in. All right, so snapper ls. Uh-oh, I expected 5, but we booted into 3. As you can see, there's a negative next to 3. Well. Well, don't worry, we can fix this. But as you can see, do sudo update grub. Let's make sure the grub submenu is all caught up with what we're doing here. As you can see, we are now all caught up. If I do sudo BTRFS subvolume get default / so the default is supposed to be 5, but we're booting into 3, so grub doesn't understand that number 5 is the default snapshot. We're back at 3, and if I do snapper ls again, 5 plus is the default, supposedly, according to Snapper, but 3- is what we're currently booted in, using the default grub boot menu. So what's worse is if I do sudo BTRFS get property, you can see that read-only is true. This is a read-only snapshot. So I can't mess with the system. This is a read-only system. So let's fix this situation. Let's reboot to a read-write snapshot we know is number 5, the top here. It goes in reverse chronological order. Number 5 is at the top. Select the kernel and boot from it. So now we're booting what we think should be the default root snapshot, which is number 5, and it should be read-writable. Okay. So let's do a snapper-ls. As you can see, there's an asterisk next to 5. That means it's writable, and it means it's both the default, according to Snapper, not according to Grub, and also the currently booted snapshot, right? Because we selected number 5 just now. So let's delete snapshot 1, because we want to create a new default root snapshot. And I like to choose snapshot number 2 because it's fairly clean. It's before we installed neofetch or neofetch test. So let's snapper delete 3 and 4. We can't delete snapshot 5 because that's currently booted. It'll prevent us from doing it. But we have snapshot 2 enabled. So we want the new default root being snapshot number 2. So let's make that happen. Let's clear the terminal and let's sudo make dir -p /snapshots 1, because it's going to be our new first snapshot, snapshot number 1, which will be the new default root snapshot. And we'll do a sudo BTRFS subvolume snapshot, and we'll snapshot number 2 into snapshots 1 snapshot. And that'll be a read-write snapshot, I think. Yeah, because BTRFS manual snapshots are read-write. Snapper is read-only. And we'll copy the info.xml file from number 2 into number 1. And then we can edit it to make number 1, the description in info.xml, reflect the new intention of our default root snapshot. So that's going to be of type single, not pre or post. Number will be 1. And instead of apt install neofetch, it'll be henceforth default root snapshot. And we want to remove number because we don't want the number auto cleanup from snapper config to erase this at any time in the future. We want to hang on to it until we manually delete the snapshot. Best practice, right? For our default snapshots. So sudo BTRFS inspect internal root ID /.snapshots 1 snapshot, and that'll be 274. So let's set that to be the default, right? It's the default root snapshot. So sudo BTRFS subvolume set default 274/. Okay. Fantastic. Snapper-ls shows plus next to the 1 shows it's the new default root snapshot. And there's no, the cleanup is blank, so it'll clean itself up. We're booted into 5, hence the negative sign. So let's reboot. Let's boot into our new single default root snapshot. It should be read-write. Yep, it's working. So let's launch the terminal. Make it full screen. Well, let's do a snapper-ls. Okay, so we've got number 5 as booted, and 1+, that's our default. Of course, grub is completely unsynchronized. So we're going to synchronize it with grub update, or update grub rather. Let's reboot one more time. Okay, so let's select the default snapshot now that we've updated the grub menu. Always synchronize things when you're operating with Snapper with by updating grub. Okay, so now let's take a look here with sudo BTRFS properties get-ts / and read only is false. That means it's read or write. Good. Okay, let's do a snapper-ls. So now both default and our currently booted snapshot is 1. So there, hence an asterisk. Asterisk equals plus, plus, minus. Okay, kind of makes sense. So now we can delete snapshots 2 and 5. And there we go. System is all functional again, and we recovered from the disaster. We've created our new default root snapshot. Let's update grub to let it know what we've done. Should always do this after rollbacks and manipulations, like I just said. So now, let's do a sudo reboot one more time. Thanks for being patient. We're almost done here, folks. Okay, the default grub menu entry for booting the system. Let's log in. Here we go. That's snapper-ls. Nice and clean. Cool. So we can go into the future together. Neofetch, of course, this is a pre-snapshot write. So we need to reinstall Neofetch. So you can do it. So you can see everything works because it's the read-write snapshot. And we can type Neofetch, and here you go. We're all done. So as you can see, my results for Snapper were not quite so simple as with Timeshift. I probably missed something with grub not able to automatically boot from the default snapshot, resulting in many more extra steps than what we're used to. If you have any theories and/or suggestions on how to fix this, please discuss in the comments section. Thanks so much for watching, and until next time, be well and have lots of fun.